Assalamualaikum and hello to everyone. In this video lesson, we will continue for part 1 of chapter 3. For this video lesson, we will cover the third subtopic from this chapter. Now, this subtopic will be quite long, therefore, it will consist of multiple video lessons. The objective for this subtopic is on the right of the screen. In this subtopic, we will apply the SFEE as seen in the previous subtopic to steady flow devices. There are 5 steady flow devices covered in this subtopic as shown in the figure given. Now, before we look at the first steady flow device, it is important that when reading the question, we must be able to identify the conditions the steady flow device is operating at. These conditions are the work interaction, the heat interaction, and kinetic and potential energy interaction. By identifying these conditions, we can reduce the general SFEE, which will make our calculations easier. Now, let's look at the first steady flow device called turbines. Turbines are work-producing devices, meaning that in terms of work interaction, work out is present and work in can be neglected. Other possible here means, depending on the question, turbines can also be adiabatic, and depending on the question, also kinetic and or potential energies can sometimes be neglected. The figure given is the schematic diagram for a turbine. Now, let's look at an example on how to use the SFEE for a turbine. For this example, we will consider an adiabatic turbine. Remember to write the conditions from the question before applying the SFEE. Start with writing the general SFEE first, and then cancel the terms based on the conditions. Rewrite the remaining equation, and to determine work output, we can rearrange the equation as follows. Now, if kinetic and potential energies can be neglected, then the equation will be reduced to as follows. Remember, this is only an example on how to use the SFEE. As you can see in the SFEE written above, there is the term for specific enthalpy H. Now, the values for specific enthalpy is determined based on the type of substance. For water or R134A, the values for specific enthalpy is read from the property table, and for gases, the term for specific enthalpy is replaced with its related specific heat CPT. Now, let's look at the first example for turbines. You can pause to read and understand the question properly. For step 1, please try to draw the schematic diagram, and please label the inlet as state 1 and exit as state 2. For step 2, to determine the inlet area A1, since mass flow rate is already given in the question, we can use the mass flow rate equation. For net work output, we will use the SFEE, and remember to write the conditions based on the question. From the general equation, cancel the terms based on the conditions. Rewrite whatever is left, and rearrange the equation to determine the work output. For step 3, determine the required properties for each of the state based on the substance. Since the substance is steam, which is a byproduct of water, we will use the property table to determine the required properties. For state 1, now for properties read from the table, it is important that we determine the phase of the state. So make sure you determine the phase of the state before reading the properties. So as you can see, the phase for state 1 is a superheated region. So using the appropriate tables, read for the values of specific volume and specific enthalpy. For state 2, as you can see, when comparing since the value for quality is given, we know that the phase is a mixture. Therefore, using the equation for mixture, we can calculate for the value for specific enthalpy at state 2. For step 4, substitute the required values and solve for the question. As you can see, the answer for the inlet area A1 is 0.00267 meters square, and for net work output, the answer is 7,132 kilowatts. Now, for the second example for turbines, you can pause the video to read and understand the question properly. Again, for step 1, please try to draw the schematic diagram and label the inlet as state 1 and exit as state 2. Don't forget to label the value for Q out since it is mentioned in the question. For step 2, to determine the mass flow rate, we will use the mass flow rate equation. To determine the exit velocity, since the mass flow rate for state 1 and state 2 is the same, we can also use the mass flow rate equation at state 2 to find for exit velocity V2. For work output, we will apply the SFEE based on the given conditions. Please remember to write the conditions which is given from the question. Start with writing the general equation. Cancel the terms based on the condition. Then rearrange the equation to determine the work output. Now, since the substance is a gas, H must be replaced with CPT in the equation. For step 3, using the related gas equations, determine the required properties at state 1 and state 2. For state 1, we have to calculate the value for specific volume, which here we can see the answer is 0.1801 meter cubes per kilogram. At state 2, we also have to calculate the value for specific volume, which here we can see the answer is 1.148 meter cubes per kg. And for step 4, substitute the required values and solve for the question. For mass flow rate, the answer is given as 66.63 kilograms per second. For exit velocity, V2 equals to 76.49 meter per second. And for net work output, the answer is 21,497 kilowatts. Now, we have come to the end of this video lesson. We will continue with the remaining steady flow devices in the next video lessons. Please leave a comment in the learning activities section on what you have learned from today's video. If there are any questions, please do not hesitate to ask. Leave a comment in the forum section. Thank you for your attention and have a good day.